Hello, this is Oliver Birch. I am here to record the homework for Lab 3 in its entirety, all the parts pertaining to the circuits. Um, so, starting here at Lab 3A, Part 1, where I need to construct and simulate a circuit to generate a periodic waveform from a DC power supply. So, after hooking everything up, resistors, capacitor, oscilloscope at the ready, through the reset, the discharge, the threshold, the trigger, the output. Running this circuit produces a square waveform, and the second channel here has this angle, is what is producing this angular waveform. I bumped this up a little bit to see what would happen if it changed, and increasing the resistance lengthened the square waveform. See, now that I have brought it back down, the heights and valleys are quite closer. So if I need to stop this simulation before moving on to the next part, this is very similar to the previous one, using a DC power supply connected into the 555 timer pinout, produces the AC waveform, but there's an LED connected here as well as a transistor instead. And so running this causes the light to flash very quickly. It's because of the high and low points of the waveform. And say if I were to increase the strength of this resistor here and run it again, you can see it flashes a lot slower, stays on for a lot longer, and flashes back down. Now if I were to increase this as well, say go from 5 to 50, I'm going to bring this down a little bit as well. This also remains flashing for quite a similar amount of time, bringing the capacitor up as well. And I'll just set this back to how it was. 1 kilo ohm. And now it is flashing quite rapidly again. Increasing the resistance lengthens the size of the waveform, and bringing it down causes it to flash more rapidly. In part B of the lab, we were instructed to construct a circuit including a 7-segment light display, such as that on a digital clock, to display a digital counter. So there's the 74393 pinout that we've used a couple times with the clock on it. There's also a 74138 pinout. So after constructing the circuit here, and including the 7-segment light display connected to the 74LS47D here, can show that when turning this on, the display over here will in fact count every time I have pushed the push button on the left next to the input of the 74LS393 IC, the integrated circuit here, counting up 8, 9. I noticed it kind of does something wonky after I pass 9. So this would be 10, 11, 12, 13, 14, 15, and then it seems to reset at 16. So that was part 1 of B. Now if I continue to part 2, which is this whole setup down here with the 74LS138N. This one will show the outputs 0, 1, 2, 3. Well, I have it set to 0, 1, 2, and 7 right now. So by starting the system, it shows that 0 is the light connected to the 0 output is on. Pushing the button moves it to the 2, or moves it to the 1. Started at 0, now it's at 1. Pushing again moves it to the 2. You can see this corresponds here. And should this come to 7, since this is put in the 7th output, now this one turns on as well. At 8, I noticed that 0 turns on again. It just keeps looping down at the bottom, even if this stops corresponding the correct number, 0. Oh, well, 2 rotations. Okay, it does still correspond. Now the messed up 7-digit or 7-segment indicator confused me a little bit there. But once it does reset, 7 back to 0 again. So that is all, and thank you for listening.